In this video I'm going to be looking at the solution to question 6 from the January 2011 Edexcel D1 paper. The topic of the question is linear programming. The question refers to a graph in a figure in the paper and which is being used to solve a linear programming problem. So two of the constraints have been drawn on the graph and the rejected region shaded out. In part A of the question, we're asked to write down the constraints that have already been drawn onto the graph. Two further constraints are given: x plus y is greater than or equal to 30 and 5x plus 8y is less than or equal to 400. We're asked to add two lines and shading to the graph which is in the answer booklet to represent these constraints and determine the feasible region and label it R. Having done that, the question then goes on to say that the objective is to minimize a function 15x plus 10y, and we're asked to do this by drawing a profit line on the graph and to use it to find the optimum solution. Well, taking these part at a time, then we're asked to first of all to draw two constraints onto the graph. The first one, x plus y is greater than 30. This will cross the axes at 30 and 30, so both axes crossed at 30. So marking that with a line, we get the following. And we want greater than or equal to 30, so it's going to be shading out everything which is below that line, or to the left if you prefer. So this is the shaded out region for that particular line, and this is the line which is x plus y is equal to 30. The second constraint that we have is 5x plus 8y is less than or equal to 400. So this time it's going to cross the x-axis at 80, so that's where 5x is equal to 400, and the y-axis at 50. So drawing that one in, we get that line. And we can label that line as 5x plus 8y is equal to 400. We want below that line, we want less than that, so shading out above it. And that gives us our feasible region R. Looking at the other two constraints that we were asked to write the equations for those constraints, the one which is going through the origin, so that's just a straight line with a particular gradient. We can find the gradient by looking at a point on the graph, and it actually goes through the point here which is at 20 on the y-axis and 80 on the x-axis. So it has a gradient of 20 divided by 80, or 1/4. Therefore, this is the line y is equal to 1/4 x. So the constraint is y is greater than or equal to 1/4 x. Looking at the other line, this has got an intercept here at 15. And if we check out the gradient, it's equal to a half. So the line is y is equal to 1/2 x plus 15. Or the constraint then is y is less than or equal to 1/2 x plus 15. That's because we've shaded out above the line and we want the values where y is less than that. Okay, that's the first two parts of the question complete. The marking, there were 2 B marks for each of these constraints, B1 and B1. That was for getting the equation of the line and then for getting the inequality. The other part of the question where we've put the new constraints onto the diagram, there was B1 for the line, and for each line rather, B1 and B1, and having done that, there was then an extra B1 for the correct shading and B1 for the region R. So there we had a total of 8 marks in those 2 parts of the question. 4 marks in part A and 4 marks in B. Moving on to the next part of the question, we're asked to minimize the function c, let's call it, equal to 15x plus 10y. Now I've put in one particular value of c, so I've actually drawn the line 15x plus 10y is equal to 150. This one here is 15x plus 10y is equal to 150. Now we can find the minimum point by then moving that line along the graph until it meets the feasible region. So just moving that a little bit at a time, we can see that the first time that it meets the feasible region is at that one corner. It's just about to enter there now, just gone past it. So we're at this particular corner of the region. Let's mark that on there. So that's the point that we're looking at, and that is giving us our optimal solution for the minimum value at x is equal to 10 and y is equal to 20. So just write that down, optimal solution. I've marked it on the graph as well, so it's x is equal to 10 and y is equal to 20. And the marking for this part of the question, there was an M1 A1 mark for correctly putting in a cost line and then moving it so that we found the optimal solution, and that optimal solution was given a B1 mark. So that's the end of that particular question. You can find solutions to other questions at www.furthermaths.org.uk.